I'm going to present some of the lessons and recommendations from the recently completed economic and sector analysis on the subject of environmental flows in water resources policies, plans, and projects. First, why did we undertake this analysis? And the bank is increasingly has been engaged in water resources, and more recently has made a commitment to scale up investments in infrastructure. And this subject, the allocation of water for downstream needs, has been one of the very contested areas. And unlike other areas of water resources management, which are very well defined procedurally and methodologically, this remains a gray area. And given the fact that our engagement is increasing, it was important for us to understand clearly how to deal with this in a very structured manner. The objective of this analysis was to help advance the understanding and integration in operational terms of environmental water allocation into integrated water resources management. And we will dwell with the terms environmental water allocations or environmental flows and integrated water resources management several times. The presentation is structured around three themes. We'll talk about the e-flow science and decision making, some of the case study analysis that we carried out, and the recommendations for framework of action. But before I continue, just wanted to highlight that there were two outputs that came out of this work. Findings and recommendations in the Blue Book that is available on our website as well as in our bookstore, and detailed case studies, 17 case studies, also available on our website. So moving forward, first the science and decision making. What are environmental flows? These are not minimum flows typically defined on the basis of hydrological conditions alone. Environmental flows are flows for maintaining downstream river ecosystems in a desired ecological state. Now, that desired state is a state that society determines. On the one extreme, it could be a high, completely degraded system like a sewer, or it could be, on the other hand, a pristine system. But oftentimes, it's somewhere in between. The key point is society decides on the state that it wants to preserve. And deciding on environmental flows is a social choice, not a technical decision. Social input is essential, but the key is that it needs to be informed by proper science. And e-flows are described in terms of dry season low flows, wet season pulses, as well as the magnitude, timing, and duration of flood events. Basically, the flow regime is a multidimensional variable entailing number of these factors: quantity, timing, duration, frequency, quality, etc. Now, why are these important? Inadequate evaluation of environmental flow requirements in water development project has led to biased and suboptimal allocation decisions, resulting in inequitable allocation of water, increased conflicts, threaten the sustainability of downstream resources, and also it has distorted the economics of projects. Basically, by ignoring downstream impacts and downstream costs, the costs don't go away. You're simply basically inflating the project economic rate of return. And subsequently, it will also lead to costly restoration in the future. The key message is that it is cost effective to address downstream impacts early in the decision-making process. Now, in integrated water resources management, basically environmental flows occur in three different contexts. First, like all other uses, environment is a user of water, and there has to be a clear procedure and methods for defining that. Second, in most of our work, when we carry out an EIA for developing water for either water supply or irrigation or hydropower, we look at the impacts on ecosystems, either upstream or downstream of that development. Environmental flows also basically feature in that process. And lastly, For this integrated water resources management framework to function, essentially we need policies, laws, etc., that recognize multiple uses of water and that have clear procedures for allocating between competing uses. So in short, water allocation in the context of safeguard policies and in the context of restoration, rehabilitation, degraded systems. Environmental flows also occur in the context of international waters in negotiating allocations between different countries. The practice of dam development has also evolved over time. In the beginning, it was the domain of engineers alone. Later, with the introduction of the project benefit cost analysis, economists started entering the decision-making process. And then in 1970, with the National Environmental Policy Act of the United States, the Environmental Impact Statement was introduced. And subsequently, there's been a greater focus on the social issues, involuntary displacement, etc. More recently, there is an increased focus on downstream issues. Examples of downstream impacts: ecosystem functions and productivity, biodiversity, fisheries, saltwater intrusion, dilution, groundwater recharge, as well as water needs for other uses that support livelihoods. There are numerous methods available to address, to understand, to define environmental flow requirements, from the simplest, the hydrologic index method, to hydraulic rating method, to habitat simulation methods, to holistic methods. Basically, the methodology IFIM has been developed in the United States. It is also utilized widely in the United States. The building block methodology and what we call DRIFT, which stands for Downstream Response to Imposed Flow Transformation, they were both developed in Southern Africa. BBM is used widely in South Africa. DRIFT was developed in the World Bank supported project for the Lesotho Highlands water project. Broadly speaking, they can be grouped into two categories: prescriptive and interactive. Basically, the first group is used to address a narrow set of objectives. The second basically is used to define multiple scenarios. And remember, I said earlier, desired state. In complex projects, it is often important to understand multiple range of flows that could be considered for ecosystem needs. And then utilizing that information along with project economics, one can make decisions. And in that context, this set of methodologies are quite useful. Now let's look at the case study analysis that we carried out. We focused on 17 case studies. We looked at 5 water policies, 4 basin plans, and 8 infrastructure projects. Used a highly structured methodology that has been developed partly by the IAIA in the context of evaluating effectiveness of strategic environmental assessments, and also some of the earlier work done on environmental impact assessment, the criteria that were used to explain the outcomes of the first part of the analysis. Case studies, 5 policies from Australia, the EU Framework Directive on Water, the water policy of South Africa, Tanzania, and Florida. And we looked at 4 basin plans: Kruger National Park, Mekong Basin, Pangani Basin, Pioneer Valley in Australia, and 8 projects from the Aral Sea to the Berg River in South Africa to the Bridge River in Canada, Chilika Lagoon in India, the Lesotho Highlands Water Project, the Lower Kihansi Environmental Management Program in Tanzania, the Senegal River, and the Tarim Basin. And some of the lessons at the policy level. Essentially, it is quite clear that if water needs for environments are defined in the policy, it will make subsequent work at the investment level much easier. It gives legitimacy to water allocations in the subsequent plans and projects. The policies would also establish priorities for allocating water, including for environmental purposes. and it can specify procedures for such allocations and provides other provisions for participation, etc., etc. Now, given the shortness of time, I will just skip through some of the main lessons. On the plan side, the plans can establish equitable distribution of water for multiple uses, including downstream users. And it can establish benchmarks for subsequent infrastructure development. But for the plan to be effective, it is important that environmental benefits are demonstrable. And e-flow terminology must be clear. Oftentimes, there is confusion whether we are dealing with the needs of birds and snails alone, or whether we are also concerned about the needs of downstream communities that are dependent on the resources. It is also important to look at the water plan as part of the whole water cycle. What we have seen is that in Australia, for example, significant regulation on surface water, and which led to major compliances, led to a distortion of groundwater. So while you are regulating one system, if you don't consider the other, there might be distortions incorporated. We have also seen that a planning process requires a wide range of environmental flow methodologies, and it can establish indicators for monitoring environmental outcomes. Lessons from the projects. Interesting examples where interesting lessons were generated. Essentially, successful restoration often requires some engineered solutions as well as flow management. Environmental outcomes need to be linked to socioeconomic outcomes for them to be acceptable. And what was actually surprising was that the cost of carrying out an environmental flow assessment in general is a very small component of the project cost. Just to give you an example, the work on the Lesotho Highlands Water Project, work was a very detailed, comprehensive assessment. It cost almost $2 million, but it led to some very significant mitigation. And if you compare it with the whole cost of the Phase 1 and Phase 1A and 1B of the Lesotho Highlands Water Project, which cost a total of $3 billion, that amount was not quite significant. Economic studies can help make the case for environmental flows. Now, in general, what are some of the achievements? Environmental flow work is actually institutionalized in many developed and developing countries, South Africa being one of them. And the applications are much broader beyond just infrastructure development and planning. And they also, in some cases, are starting to apply to, they extend to groundwater, estuaries, and nearshore areas. The science of environmental flows has evolved considerably. There are numerous methods available. And there is substantial experience outside in the international agencies and NGOs. They are doing some fabulous work in this area. Some of the challenges, as I mentioned, terminology and perceptions remain a challenge. Integrating groundwater, estuaries, and nearshore in environmental flow assessment is still an early area. And flows are also influenced not only by developments on the river system, but also by changes in the catchments, land use changes, etc. And those are areas that have not received enough attention. And this meeting is focusing on integrating climate change impacts, clearly a huge challenge. Integrating environmental flows in EIAs and project assessments remains a key challenge. The work of the bank has both informed by and contributes to evolving global knowledge on environmental flows. Some of our experiences are listed there. And to date, successes are more from individual leadership rather than bank processes. And I think it's key now to move from individual successes to a more structured and institutionalized approach. 4 set of recommendations to do the mainstreaming. One is to strengthen the bank's capacity. Second is to strengthen the environmental flow assessment in project lending. Third is to integrate environmental flows at the policy dialogue and planning levels. And fourth is to expand our collaboration. Very quickly, these are some of the outputs that we have generated on the subject also, and more recent ones.